Hi guys, my name is Muhammad Aiman Hafiz bin Rozmi. I'm from class A4AS1201_1. Today I'm going to talk about redox equilibrium. In this topic, I will be covering two subtopics, which is oxidation and reduction and also rusting. Redox reaction. What is actually redox reaction? Redox reaction is a chemical reaction where oxidation and reduction occurs at the same times. Redox. Interesting word, isn't it? Redox actually derived from reduction and oxidation, which is red come from reduction and ox come from oxidation. What is the difference between oxidation and reduction? There's a few actually, 4 to be precise. One of them being reactant in oxidation will gain oxygen, while reactant in reduction will loses oxygen. In terms of hydrogen, reactant on oxidation will lose hydrogen, while in reduction will gain hydrogen. In terms of electron number in oxidation will decrease, while electron number in reduction will increase. In terms of oxidation number of an element in oxidation, it will increase, while in reduction, otherwise it will decrease. Oxidation and reduction in terms of gain and loss of oxygen. In this situation, as you can see here, magnesium being oxidized by oxygen, while oxygen being reduced by magnesium. That makes magnesium is reducing agent because it causes oxygen to be reduced, while oxygen is oxidizing agent because it causes magnesium to oxidation and reduction in terms of gain and loss of hydrogen. As you can see here, hydrogen sulfide is actually being oxidized by losing hydrogen to chlorine to create sulfur. On the other side, chlorine is actually being reduced because it gains hydrogen to create hydrochloric acid. As you can see here, chlorine is actually oxidizing agent because it causes hydrogen sulfide to oxidize, while hydrogen sulfide is reducing agent because it causes chlorine to be reduced. Oxidation and reduction in terms of electron transfer. Actually, not all redox reaction can be proved by gain and loss of hydrogen and oxygen. Since the discovery of electron by J.J. Thomson at 1897, this method being used by chemists to prove redox reaction. This is where we will learn about half equation. As you can see here, magnesium is actually being oxidized because, as you can see, magnesium loses electron, while you can see in the case of oxygen, it gains electron, make it as reduction. That also makes oxygen as oxidizing agent, while magnesium is reducing agent. Next, we have redox oxidation and reduction in terms of change of oxidation number. This method was created because of chemists found that electron transfer in redox reaction is limited to ionic compound. Oxidation occurs when oxidational number increase, while reduction occurs while oxidational number decrease. In this example here, as you can see, carbon is actually being oxidized because it gains oxidation number, while oxygen being reduced because it loses oxidational number. That makes oxygen as oxidizing agent, while carbon is reducing agent. Both of them combine to create carbon dioxide. In this part, I will be explaining about laboratory experiment in proving redox reaction in terms of electron number. As you can see here in the green side, you actually have iron 2 sulfide. Iron 2 ion will lose electron to create iron 3 ion. The other side, you have calcium manganate. Manganate 7 ion will receive electron to create manganese 2 ion. As you can see down here, we have the equation of it. First, you can just list out all the half equation and then just cancel out the charge, and then you get the ionic equation of it. What is actually oxidation number? Oxidation number is the charge of the element in a compound if the transfer of electron occurs in an atom to form chemical bonds with other atoms. Can be determined as the following guideline. You can see this guideline is actually the way to find your oxidation number. In this part, you'll be learning the oxidation number and the naming of compound according to the IUPAC nomenclature. Roman numeral is actually being used to indicate oxidation number in an element. As you can see, the example here, you have ferrum 2 and ferrum 3 ion. The rest you can refer to the table below. Displacement reaction of metal from its salt solution. It occurs when the metal is added to another salt solution of another metal. As you can see, the more electropositive metal actually can displace the less electropositive metal from its salt solution. As you can see the example down here, you have copper 3 nitrate solution with zinc. The color blue of copper nitrate solution becomes paler because of concentration of copper decreases. Brown solid deposited. Copper ion receive 2 electrons to create copper atoms. Copper ion is being reduced. In the case of zinc atoms ionize to create zinc ion. Zinc actually being oxidized because it loses electrons to create zinc ion. You can see the chemical equation down here. Electrochemical series. As you can see, as the strength as oxidizing agent increase, the list goes down. As the strength of reducing agent increase, the list goes up. Here comes the second part of my presentation, which is rusting. What is rusting? Rusting of an ion is basically when it's a chemical process that involves water, oxygen, and undergoes redox reaction, while metal corrosion occurs to iron and other metals too, such as silver and copper. So, what is corrosion metal actually? Corrosion metal is a redox reaction where the metals is oxidized spontaneously when the metal atoms release electron to form metal ion. In general, the more electropositive the metal is, the easier the metal to corrode. For example, corrosion of iron is faster than copper. This is the redox reaction of an ion. As you can see, the surface of the ion in the middle of the water droplets is actually where the concentration of oxygen is the lowest, which is served as anode, aka negative terminal. In this case, ferrum atom is actually being oxidized by losing electrons to create ferrum 2 ion. The other side, oxygen O2 that dissolves in the water droplets accepts electron and undergoes a reaction to form hydroxide ion, OH. What is the way to prevent rusting? Use protective surface. This method actually can prevent the metal from being oxidized. So one of them being paint, grease, and plastic wrappings. You can paint for fences, car and bridges, oil and grease for car engines, and plastic coating for wire fences. Using other metal also can. The terms we use here, galvanization. Iron steel is galvanized with a thin layer of zinc. Tin plating, tin form a layer of oxide protection. Chrome plating used on bumper car, bicycles, and decorative items. Next, we have sacrificial protection. The more electropositive metals become sacrificial metal. Sacrificial metal is actually need to be replaced from time to time. Sacrificial metal usually involved in the big things such as bridge pillars, ship hulls, and underground pipes. Thus, we have alloying. In the stainless steel, iron is alloyed with carbon, chromium, and nickel. Chromium and nickel create a shiny, protective, and corrosion-proof oxide layer. Stainless steel is widely used in surgical instrument and kitchen utensils. And this is the end of my presentation. Thank you so much for having me. I hope you understand. And thank you. Bye.